Alright, so again, on C, it looks a bit tougher because we have two square roots now, which looks terrible, but don't fret, you're not a guitar. Shouldn't have frets. Alright, so the first thing that we're going to deal with are those square roots. What I'm going to do is I'm going to try to get the square root that looks the worst all by itself. So frankly, when I say the worst, this one looks longer to me and more complicated than just the square root of x. So I'm going to single-handedly try to get this one by itself. So how I'm going to do that is I'm going to add that square root of x over with that 1. So I'm going to have the square root of 2x plus 1. Going to make that square root a little bit smaller. Is equal to 1 plus the square root of x. Alright, so the next step, just like before, if I have a square root, how I undo square roots is I have to square it. Oh, I'm going to square the entire item. So, squaring a square root, this side's the nice side. I should be left with 2x plus 1 is equal to, well, 1 plus the square root of x times another quantity of 1 plus the square root of x. And if I'm like you guys, I'm just like, okay, I might not be so good at distributing square roots as I am whole numbers. I can't just jump the gun and be like, okay, this is what it is. If you've noticed some patterns like I did up on this step on B. Alright, so distributing this out, I should get 1 times 1, which should just be 1. 1 times the square root of x should just be positive square root of x. Square root of x times 1 should give me another square root of x. And then square root of x times square root of x, well, that's when we keep the square root and we multiply what's underneath. So what's x times x? Well, that's x squared. So all in all, square root and an x squared, well, square root and square roots, they cancel out, so leaving me with just an x. Add my like terms. These both have a square root, so I can add those together. So how I add those together, square roots are kind of like a variable all on its own. So I've got 1 plus 1 out in front, so I've got 2 square roots of x's. Everything else I just carry down, and that's still equal to that 2x plus 1. Alright, but this step right here is why I say choose the path of least resistance. So get the nice one over to the other side, leave the harder one to get by itself so you can square it and get rid of the grossness. Alright, so now I've only got 1 square root to deal with, but I still need to get that by itself. Alright, so let's go. Subtract that 1 over, I should now get 2x is equal to 2 square root of x plus x. Subtract that x over, I should just get x is equal to square root of x. Alright. And then subtract that 2 over, I should get x over 2 is equal to the square root of x. Alright, so squaring both sides to get rid of that square root. Alright, squaring fraction looks bad, but all we're going to do is basically distribute that exponent to every single item in that fraction. So I would get x squared over 2 squared is equal to now x, because square roots and squareds again cancel out. X squared can't be reduced anymore, but 2 squared can, so that's 4 is equal to x. So again, I have a quadratic even though it's part of a fraction, so there's one thing I need to do first. To try to solve a quadratic, I need to get one side equal to 0. So I'm going to subtract that x over because that looks nicer. So I get x squared over 4 minus x should be equal to 0. Or you can rewrite it as 1/4 x squared minus x is equal to 0. Why I would suggest changing it a little bit because now it's a little bit easier to see that I have a greatest common factor between those two terms. And that's an x. So let's factor that out. I've got an x times 1/4 x minus 1 should be equal to 0. Cool. So now we know that this factor or that factor is 0 because 0 times anything is 0. So one of those things that's being multiplied has to be 0. Maybe both. But I know that x is one of my factors, so I know that that could possibly equal 0 all by itself. Well, that one's already solved for x. Easy enough. The next one, I've got 1/4 x minus 1 could also be equal to 0. So solving for x, add that 1 over, you get 1/4 x is equal to 1. Multiply both sides by 4 to get rid of that denominator, so I get 1x is equal to 4, otherwise known as just x is equal to 4 if that 1 out in front bothers you. So my two possible solutions are 4 and 0. As long as this has been, we're not done yet. Sorry, guys. So now, I still have to do that thing where we go back and we check for extraneous solutions. How I do that is I'm going to take my two answers and I'm going to plug it back into the original equation and see if it works. So, plugging 0 in, I am going to go see if I get 2 times 0 plus 1 minus the square root of 0. And I'm hoping it equals 1. Well, 2 times 0 gives me 0, plus 1 will give me the square root of 1, minus square root of 0. People get wrong a lot. The square root of 0 is 0. Okay, square root of 1 is 1, minus 0. Surprise, that one checks out. Next one I check, I have to check to see if 4 works, so I get the square root of 2 times 4 plus 1 minus the square root of 4. Hopefully still equals that 1. So I get 2 times 4 gives me 8, plus 1 gives me 9, minus the square root of 4 equals 1. Square root of 9 is 3, minus square root of 4 is 2, equals 1. That one also checks out, so this one does not have an extraneous solution. Nice!